Welcome everyone in today's knowledge sharing session. In today's session, I'm going to cover toggle force curve analysis. So, if we want to design a toggle mechanism, we need to know few requirements like force curve, life cycle, safety and code requirement, cost, travel angle. We may need to know other requirements like craftsmanship, color, finish. So now we got the force curve. So this curve showing force variation with rotation angle. So we want forces initially increase with angle rotation, and after a certain angle it should go down, then it remain constant. So by knowing this curve, we found one concept showing in this picture. So here we have one paddle in gray color. It can rotate plus minus 30 degree with respect to neutral position. In white color we have hinge pin. In red color we have spring loaded plunger. Blue color mounting bracket. So to analyze the forces in the system, we need to create free body diagram. Generally, it provides us different contact point in the system and also direction of force. So in this case, we are creating two free body diagram, one at paddle at 0 degree and other at 20 degree angle. So at 0 degree, we have F1 force applied by user to paddle, F7, F6 forces at hinge, F2, F3 forces at contact point between plunger and paddle. Same F2, F3 also goes to plunger. F4 and F5 two other force which act in horizontal and vertical direction to plunger. At 20 degree we have F8 force applied by user to paddle, F9, F10 forces at contact point between plunger and paddle, F9 generally reaction force, F10 friction, F11, F12 forces at hinge point. F9 and F10 also goes to the plunger because these two forces are acting in horizontal and vertical direction, so that's why we have two other forces in opposite direction in plunger. So free body diagram tell us only direction of force. We still don't know what is the magnitude of force. So to know the magnitude, we have two process. One, create CAD model and find contact point and torque R. Second, use geometry formula. First formula, first process is really very difficult if we have so many concepts. But second concept initially take time, but it's very helpful to analyze system. We can easily optimize our system by creating few formulas, but CAD model creating for each and every concept it's really difficult and time taking. So there are some useful formula which can help us to optimize the system. First, line equation passing through x1 y1 x2 y2. Second, normal distance between line and point. You can use this formula. If we have point P x0 y0 and line AX plus BY plus C, this formula can provide us normal distance. Third formula, distance between point x1 y1 x2 y2. This formula can provide this distance. Fourth formula is really very useful. Generally in toggle system we use few terms like rotation angle, arc radius. So this formula really help us to convert the polar system to Cartesian system. So now we have a free body diagram. Now we can start creating the equations. So in this case, line is nothing but force direction. So whatever free body diagram saying us the force direction, we need to form the line in those direction. And contact point is nothing but the forces acting on component like F1, force applied by user at which location we need to apply. Hinge location, we need to know the hinge point. We need to know the contact point between the paddle and plunger. So these contact point we need to know. And by using these formulas, we can really easily create a small mathematical model which can help to analyze the system. If you have any problem, if you want any help, please contact us. We would really like to help you out. Thanks for watching video. For more useful video, please subscribe our YouTube channel Public Knowledge.